Good morning, all of you. So today we are going to learn very important topic, and even in IP exam they are asking this question for 4 marks. So what is that topic? Critical angle and total internal reflection. Okay, what is that? Critical angle and total internal reflection. Okay, so what is this? Let's start from critical angle first. First, I am writing the definition of this critical angle. And for this, let's draw a diagram. Suppose now this is interface and there are two mediums. One is denser and another is rarer medium. And here is object. Okay, this is point O. And this medium is which medium? Denser medium. This medium is denser medium. So therefore here mu of, let us suppose, denser medium. D for denser. And this medium is rarer medium. And this is denoted by mu R. Okay. Now, as this is denser medium, which is below, so from this, light rays will refract in different directions. This is normal, so therefore it will go undeviated. Next one, as angle of incidence increases, angle of refraction also increases. It bends away from the normal. This will graze this surface, and if you are incidenting beyond this, then the ray will get reflected back into the same medium. So this red one, I am drawing normal. these whatever I have drawn, that is normals. So this angle I am denoting now. This is suppose R, this one is I. Then this one is R1, this one is I1. This is 90 degree. Okay, what is this? 90 degree. And this is I am denoting as a IC. IC means critical angle. And this is again I2, and this one is R2. And let's give some points also. So I will give here this as a P. Okay, this is P point, this one is Q, this one is R, this one is S, and this one is T. And these are the normals N1, N2, N3, and N4. Right? And as this is denser medium, you can keep some dots in this. Okay, so that you will get to know that this one is the denser medium. Okay, some difference in the medium. Right. Now, what is this critical angle? Okay, what is this critical angle? So you can see at point S, the angle of refraction is how much? 90 degree. So can I define like this? See here, what I am writing here. Angle of incidence, angle of incidence in a denser medium, angle of incidence in denser medium for which angle of refraction the angle of incidence in a rarer in a denser medium for which angle n is missing here, for which angle of refraction is 90 degree in rarer medium is called critical angle. In diagram, IC is critical angle, है ना? IC is critical angle at point. Yes, you can see here. Okay, understood this critical angle, right? Next one. What is total internal reflection? What is the total internal reflection? Total internal reflection. Total internal reflection means when light is coming back into the same medium, complete light is coming back into the same medium. So let's see what is this total internal reflection. From point O from point O, light refracts in different direction as shown in figure. As shown in figure. Yes or not? You can see first ray is going straight, next one it is bending, then again more bending, then again more bending, and then getting reflected into the same medium. So as angle of incidence increases, angle of incidence increases, angle of incidence increases, what happens? Angle of refraction, angle of refraction also increases up to certain point, right? Beyond critical angle, beyond critical angle, that is that is angle of incidence greater than critical angle, then what happens? The light ray reflects completely in the same medium, completely in the same medium this phenomena is called total internal reflection. This phenomena is called this phenomena is called total internal reflection. Okay, this phenomena is called total reflection. This phenomena is called total internal reflection. Okay. Light ray reflects completely in the same medium. This phenomenon is called total internal reflection. in diagram you can see at point T, at point T, total internal reflection occurs. Okay, in diagram at point T, total internal reflection occurs. Okay, understood, right? Let's move ahead. What are the conditions for total internal reflection? Okay, conditions for total internal reflection. Conditions for total internal reflection. What are the conditions when we can say that total internal reflection will occur? So first condition, see, light rays should travel from denser to rarer medium. Okay, first condition, light should travel from denser to rarer medium. Okay, means light should be always from denser to rarer medium. And second number condition is what? Angle of incidence. Okay, what is that? Angle of incidence should be greater than critical angle, है ना? So therefore this is the condition. What is that? Angle of incidence should be greater than critical angle. That is, angle of incidence should be greater than IC, critical angle. Okay, then only total internal reflection will be possible. Got it? Okay, next let's move ahead. Now see here at point S, or I can say relation between refractive index and critical angle. So simple heading I will give first. That is what? Relation between critical angle and refractive index. Okay, so let's come back to the diagram. At point S, you see, can I use like this? At point S, what I am doing, see carefully. At point S, I am showing you diagram again. See here. Now this is what refractive index into this angle mu d sine of IC is equal to mu r sine of 90. Can I use this? So therefore mu d, that is the refractive index of denser medium, into sine of critical angle is equal to mu of rarer medium into sine of 90. So therefore the sine 90 is equal to 1. So this is going to be mu r, and this is what? Mu d into sine of IC, right? So if I am transferring this mu r here and this sine IC this side, then we are getting mu d by mu r is equal to 1 by sine of IC. This is what the relation between refractive index and critical angle. Relation between refractive index and critical angle. So if I want just critical angle, then from this only I can do like this: mu d by mu r is equal to 1 by sine IC. and therefore sine IC is equal to mu R by mu D. Yes, taking reciprocal. And therefore, if I want critical angle IC is equal to sine inverse of this refractive indices. Okay, understand? So if they are asking you critical angle of these two mediums, just you substitute the refractive index ratio and take sine inverse of that, you will get the critical angle for particular that medium interface. Okay, so let's see some examples. So note point, we can say these values you can keep it in mind. So whenever you want to solve any problem, that time it will be very useful to you. So what is that note point? See, critical angle and refractive index also. So first one, glass air, glass air medium. Okay, for glass air, what you are getting? Mu of denser medium is how much? 3 by 2. Mu of rarer medium is what? 1. Then theta c is equal to what? Sine inverse of 2 by 3. Okay, and therefore critical angle for this interface is how much? 42 degree. Keep it in mind. Second one, second interface, suppose water and air. Now which medium is denser? Water. Which medium is rarer? Air. So mu for denser medium here is how much? 4 by 3. Mu of air is 1. Theta c is equal to sine inverse of 3 by 4. And here critical angle is equal to 49 degree. Okay. Third one, glass and water. Glass and water interface. So now which one is rarer and which one is denser? Yes, which one is rarer? Water is rarer, glass is denser. So therefore mu D is equal to 3 by 2, mu R is equal to 4 by 3, theta C is equal to sine inverse of, karo, how much? 8 by 9. And here critical angle is equal to 63 degree for glass water interface. And one more, that is, let us suppose you are having diamond and air. What is there? Diamond air interface is there. Then which one is rarer medium, which one is denser medium? Obviously diamond is denser medium, so therefore mu of denser medium is 2.5, mu of air is 1, so theta of or critical angle is equal to sine inverse of sine inverse of 1 by 2.5, and here in this case theta c is equal to how much? 24 degree. So basically in the all formulas we have denoted it with IC, so you can denote it with IC only if you want. Okay, here also IC. Critical angle are denoted in with the letter IC, no, so you can denote with IC only, not an issue. Either theta c or IC, choice is yours. So let's denote it as a IC. Here also IC, critical angle IC. Here also IC. Okay, understood? Yes, so note down this all. Relation between critical angle and all these things. Next, this one, conditions and this diagram. Okay. right? And these node points also. So let's stop here for today. Bye.